Hello and welcome to episode 71 Tackling Space Debris, RECA's Vision for Space Sustainability. We previously have discussed some of the topics which are related to space debris, but haven't taken a really deep dive into the topic and the kind of company's goals. And from a perspective, especially the software, we have always discussed things from a hardware perspective. So, today, to take a deep dive into this topic, we have with us Dr. Agnes and Dr. Stevo. Hello, welcome to the podcast, both of you.
Hi, Omkar. Thank you very much.
Hi, I'm Car. Nice to be here.
Yes. Yes, thank you very much. Yeah, thank you very much for your time, basically. Yeah, and I think, before taking a jump into the topic itself, can you, both of you, provide a brief introduction about yourself, like what inspired you to basically take up such a innovative path towards, the software related stuff and take a jump into the space industry, especially. So can you tell us a brief about, about your background and how you ended up doing what you're doing at the moment?
Sure. Should I go first? So,
Yeah.
Agnes, I always had this passion for aerospace engineering. And so after high school, I furthered my studies in France, did a double master's oriented towards aerospace engineering in Toulouse. I then furthered my studies, completed my PhD in Bordeaux under the French Department of Defense, where the topic was computational physics focused on hypersonic aerodynamics. So after my PhD, I moved to Switzerland, and then together with Thibault, we kind of identified a gap in commercial solutions compared to what we were working on before, which became the main inspiration on why we launched VCAE, our startup, and also, of course, to continue our passion in space. Over to you, Thibault.
So yeah, indeed. I am also an aerospace engineering graduate originally. So I've been in this space industry maybe now since 2014, I would say. So it's been nearly 10 years. I originally started my career working with the French Space Agency on our European rocket Ariane. And then I transitioned also to the French, Department of Defense, the same division as Agnes was in, and I was in charge of a team there where we were building orbital dynamic software and atmospheric reentry software. After my time in the DoD, I went a little bit outside and I explored AI related technologies really. And when we started thinking about building something with Agnes, we actually put everything on the table and came that we have aerospace, AI, and all this knowledge about orbital dynamics and reentry. So we decided to really bring all this knowledge together and do something for the civilian industry here. And that is really why VK was born, to really bring high performance, high fidelity software to the civilian industry to tackle especially space sustainability issues.
Interesting. Yeah, I think we always have a diverse set of people who come into the space industry. And I think previously had a brief conversation about, like in the space industry, there are several conferences, everything happens. But I believe the software and the ground segment are something that is not much discussed basically in the industry, though it is one of the I would say very crucial component of the industry. Like without software, really things can't work, and things are really moving towards software. We see the software defense satellites also which are coming in. So, before I would say taking a direct jump into the topic itself, can you start by giving us an overview about your company, RECAE, and its core mission?
So the mission of RECAE is really about bringing sovereign and autonomous operating systems to spacecrafts, right? So the long-term vision, the big vision, the big hairy goal that we have at RECAE is really to create this AI-based operating system that all spacecrafts will one day run on, so that they're completely autonomous. But on the way to this mission and on the way to this vision, at the moment we have built software to generate data to train those AIs. And the software to train those AIs actually is about orbital flight. It's about atmospheric reentry, which is actually the end of life of satellites. And everything that we've been building is completely adequate for space sustainability, right?
Yeah.
There was we identified a gap in commercial tools in terms of precision and performance for these uh, for these uh, for these physical modeling aspects, and we decided to jump in. Right, we decided to jump in because anyways we would have to build those software to generate enough data to train our AI. So we decided to go and start advertising these capabilities that we have, high precision capabilities. And our mission, that is to bring autonomy to spacecraft, actually also is to bring autonomy in terms of security and safety in space. And this is what we are doing right now. So in orbit, we can deal with this, and also end of life, where we make sure that nothing is going to fall in uninhabited areas, for instance, or we make sure that everything will be completely burned during reentry. So this is really the core mission, right? Bringing safety, bringing high precision, high fidelity solution to for a more sustainable future of our orbital space.
Interesting. And what inspired the founding of your company and how its vision has basically evolved since its inception? Because I believe you started with one aspect, and I think things are now would have basically branched out as you're progressing and evolving and expanding as well at the moment. So can you give a brief about that?
Yeah, sure. So the very core in the beginning, when we launched the company, we had this core technology on CFD computations that was developed during COVID, actually. And then when we had this idea of launching the company, we started broadening the scope of solutions, I would say. And that is how the vision of the company had evolved since its inception. So like we mentioned a few times, we did identify this huge difference in terms of precision and performance for commercial tools when we have developed different and better solutions, I would say, in military applications. So when we started the company, what we wanted to do was this technology transfer from military applications to civilian applications. And since then, I would say quite a lot in terms of vision has changed, definitely depending on the product market fit and the need of clients in the market. So the scope of solutions definitely had broadened. Instead of just focusing on CFD solutions and atmospheric reentry predictions, we now offer a wider range of modules, I would say, that covers also space mission operations, from mission planning to flight dynamic analysis and anomaly detection, for example. These are what we want to bring to the table is an advanced mission planning tool to help bring automation to space operators. And other than that, of course, there's also the technology development where Thibaut have been very implied in our flight dynamic software, especially. So yes, Thibaut has been putting a lot of focus on bringing in high performance, high fidelity solutions for space actors. So that's how I would say that's how our vision and goal had evolved since our
Yes.
inception.
Yeah, that's I would say that's a quite an innovative path. And as you mentioned about several of the aspects on the technical side, I'd like to now take a jump into the actual topic. So space debris is a growing concern for space missions. I mean, we all know that it has been a grave problem, and people are trying to solve in several regions, whether it's Europe or US or even in Asia. So how does your company approach this problem uniquely? Because we have seen that there are several other companies also operating in this domain. So what is the unique capability that your company brings in to solve this issue in the industry?
So I think in this sense, we can maybe pinpoint two main aspects for VK. But maybe before that, let's just take a quick step back. It won't be too long. What about the landscape, right? So we have nowadays there are a lot of companies that start popping up all around the world, as you mentioned, US, UK, Asia, that really are concerned about observations. So they observe our near Earth orbit and they catalog basically all the objects that are found up there. So it's debris, spacecrafts, and those catalogs, of course, are for sale, right? So this is data that we can use. One of those really well-known provider is actually the U.S. Army itself, where the Space Force provides free data to everybody. And then there are companies that are concerned about not cataloging, but trying to understand how can we remove those spacecrafts and debris out of the orbit when they are defunct and when they are just junk. So those companies, there are not that many of those companies. There are maybe a couple in the world. And then in this niche of people who want to remove things, there is now also OEMs that are starting to think about how can we build new components that can be put on any kind of spacecrafts to help with this phase of removing a debris. So this is the landscape, and then RIKE here is really focusing on software, as we mentioned several times. So we are not observing. We don't have any observation capabilities. We use that data, so we are an observation data user, and we support those companies that want to either build components for end of life or that actually want to go up there and remove debris actively. So this, I think, is already a uniqueness in a sense, because we really are building a suite of tools that is what we call end-to-end. And let me just maybe precise what that means. It's end-to-end in the sense that from the moment where the spacecraft is in orbit, all the way to the end of its life, yes, we have been dedicated to building high precision and high fidelity software to make sure that everything will go well in terms of sustainability. So when it's in orbit, we're talking here about what we call orbital propagation, which is how do you simulate and how do you predict your orbit in mid to long term. But this tool can also be used to say, okay, are we sure that there won't be any collisions between two objects in space, right? A debris and a spacecraft, or a spacecraft and a spacecraft. So collision warnings is also something that we provide to our users. And then to complete this package of sustainability, I will say, of how do you not create debris in space, we also offer maneuver suggestions to those operators that maybe do not have their run book for collision avoidance. And this forms a complete package where if an operator decides to go with us for collision warnings and collision probability and collision avoidance, then they really have the complete package of, okay, we can simulate your orbit, we can tell you whether or not there are going to be any issues, and we can even suggest maneuvers that you can make to avoid those issues. And this is for the orbital life. So this is really how we use high fidelity flight dynamics computation to track, predict, and really manage, in a sense, or mitigate space debris. And then we go all the way to the end of life of spacecrafts. And when it comes to debris and the end of life, if you're talking about a geostationary spacecraft and it's going to move to its graveyard orbit, it's not too complicated a maneuver. There are still some risks involved, but it's not the most complicated of maneuvers. But when you're talking about low Earth orbit LEO satellites, then the option for now for almost all these satellites is to come back down to Earth. Yes. Coming back down to Earth has several challenges. You're going to cross multiple orbital layers that are very busy at the moment. The orbit between 400 and 600 kilometers altitude is maybe the busiest orbit of them all. So if something is coming back down, you're going to cross all those layers. So you must make sure that you're not going to cause any collisions. And then when you burn in the atmosphere, pieces are going to detach from your spacecraft naturally. And those pieces will continue falling back down. And what we offer here is that we are really applying our re-entry knowledge that we brought with us and our AI knowledge as well to make sure that those re-entry computations are accurate enough and that we can do them fast enough to ensure that the spacecraft is either going to be completely destroyed right? Because some of those spacecraft are completely burning in the atmosphere. Or if there are some pieces that are maybe too strong, too solid, then we make sure that those pieces are going to fall somewhere in the Pacific Ocean, something like that, right? So this is really how we
Yes.
approach this problem of, it's not that we want to remove what is up there. It's not that we want to just look and observe and catalog and make sure that we know everything that is up there. We actually want to make sure that it is not going to proliferate, right? So we offer
Yes.
the tools to make sure that it's not going to get any worse than it is at the moment.
Interesting. Yeah, I think you mentioned about the collision avoidance service as well. I think you explained the complete technology and the software solutions of your company as well. To take a little bit step ahead, I would say. Can you also tell us more about the kind of space software that your company has developed and how basically it integrates very well with your overall business strategy?
Let me continue on this. I might have moved a little bit forward too fast indeed. Yes, but it's exciting times. So we always like to
Yeah,
talk
yeah.
about what we are trying to achieve. So this technology, so there are two aspects, I believe. Once again, two aspects. The first is that we are already using that technology. Users are already leveraging our technology to address those debris challenges, right? So it is the core of our current business model in that sense. Leveraging our technology in multiple ways. A SaaS platform, which is really a dashboard that you can access from any kind of web browser, for people who really just want to go and have turnkey solutions. But of course, we also integrate directly with the workflows of satellite operators, because the point here is that it's to offer more tools, not to offer more complexity. So if there's already a workflow that is established, and it's often the case, then we seamlessly integrate into that workflow via what we call APIs. And then the second aspect of these tools and business model is that we need our software to build enough synthetic data to go to our vision, right? Our vision is to bring an AI-based operating system for autonomous spacecrafts. And to train those AIs, we need data. Data is a little bit scarce out there in terms of space flight and orbital flight and all these. So we do need to supplement that data with synthetic data.
Yes.
And that synthetic data is going to come from our softwares that are thoroughly validated, very high fidelity, capable of simulating with high precision all the phenomena that are in space. And so we are going to run those softwares to feed the training data sets as well. So it is the core of our business model at the moment, and it is actually completely pivotal for what we are trying to achieve also in the future.
Interesting. And I mean, your company is basically operating on a several innovative paths, I would say, at the moment. And there are definitely some of the challenges when something new comes in the market. There are always challenges because people don't understand it. So in general, from every aspect, whether it's business, technology, or whether gathering funding, so what are some of the biggest challenges that your company faces at the moment, and how is your team addressing them as a complete, I would say, as a collaboration between some of the brightest minds in your team?
I think you did touch point on one of our biggest challenges right now. It's definitely market education.
Yeah.
So I would say space activity is growing very fast, but not many organizations or stakeholders are actually fully aware of the risk posed by space debris or how advanced solutions are available to mitigate this risk. Market
Yes.
education is definitely one of the biggest business challenges, and how is the team addressing it? I would say outreach and advocacy is one of the most primary and straightforward steps that we're taking. So actively engage in outreaches. Recently, we were involved in a few workshops. For example, Thibaut had the occasion to give a speech to showcase our solutions in front of different stakeholders. And I was also traveling in India to meet different stakeholders, engaging with different actors, so spreading awareness. And then there's also demonstration and pilot programs where we can showcase the effectiveness of our technologies, for example, and also give it a very first-hand and basic idea on what our type of software or advanced software solutions could bring to the table to solve the space. Solve the space debris problem is not the right word, but to mitigate the space debris issue. Then, of course, there's also the technical challenges. Maybe Thibaut is more apt to answer this question, but I mean, technical challenges is more on optimizing performance of our software. For example, we did mention a few times that we are focused on bringing high fidelity solutions, meaning accurate and also high performance, so that clients get solutions in a very short amount of time. So scaling our solutions to meet this growing demand is a significant technical challenge for us. So to address this challenge, we are focused on optimizing our algorithms. Right now, we are expanding the team, and we are looking for people that have expertise in flight dynamics and also computer science to employ advanced computing techniques to handle large-scale data processing and to make sure that our solutions can scale efficiently. So I would say these are the two main challenges that we are facing.
Interesting. Yep. I believe the market education, of course, is the prime thing. I mean, there are several aspects where some of the new companies, when they make an entry into the market, it is always difficult to basically, convince people or convince investors or make them understand the things. And I think the communication aspect increases. I think my podcast basically actually serves kind of a bridge over this domain only, that I try to basically bring on board the new experts, the new innovative companies, and simplify the things the way we are having the conversation at the moment, so that people are coming to come, therefore I mean people will be coming to know basically, okay, so and so technology is there, and that's how things will be working out. So I think the communication aspect is something that needs to be changed as well in the industry, and I think I'm one of that person in the community who's trying to basically do that change.
Yes, of
So
course.
yeah.
Yeah, I think it's a great initiative for sure, and engaging with media, spreading awareness is the first step to
Yes,
spread
yes,
awareness.
absolutely. Yeah, yeah, absolutely. And just I would say, taking a step ahead, I mean, we have previously answered this question in a brief manner, but still, from I would say a high level perspective, what sets your company apart from other entities who are working primarily on the space debris and space sustainability solutions? Because I believe there are not so many, but of course there are still few players in the market who have started working on collision avoidance services and all, maybe in Germany or even in the US, or there are some companies in France, I think, as well. So from that perspective, what sets your organization apart from these entities?
I believe that Rike stands really on its own a little bit, because of the experience and the algorithms that we're bringing with us. So the thing is that we are not somewhat new in this domain, even though the company itself is new. We have been doing this since maybe 6 or 7 years now, in other contexts, of course, but those other contexts required a level of accuracy that is way greater and way superior to what we need to prove today. So this is really our strong suit here. Really, when we say high fidelity and high precision, those are not just buzzwords. It's really what we are bringing to the table. And I think users are starting to recognize this, right? So in terms of orbital flight, our strength comes from the fact that we really have a high performance computing background injected into all this, which allows us to have performances that are not really seen out there. So one example of this is what we are focusing on for collision warnings, for instance, is to warn ahead of time, and enough ahead of time that even those spacecraft that are only equipped with electrical propulsion, for instance, which is known to be a slow way of moving around, have time to move around, right? So
Yes.
7 to 10 days ahead of the possible collision is what we're trying to offer here. And the reason why we can do this with the same accuracy at the end of the probability of collision is exactly because we are putting together everything we learned in the past 6 or 7 years doing orbital flight. And then
Interesting.
and then I think what really people are starting to recognize is that with everything that's happening with the FAA, with the European Space Agency, with all those new sets of recommendations and laws and sometimes fines that are starting to be created and given, people are starting to slowly recognize the importance of having a strong end of life strategy. This was not the case 6 months ago, even a year ago, when we were talking with partners at ESA. This was not really the top thing on their mind because every time the same answer was coming, which is, my satellite only has been there for 10 years. I still have 5 or 6 good years in front of me. So I don't really need to worry about it, which is fair, But there was also no real recommendations or rules at that time that really said, if you get back in the atmosphere, you just need to really burn. That was the vague term. And now there's starting to be numbers on this. And actors are starting to recognize that to reach those numbers, you need proper prediction capabilities. And I think this is where we enter strong on the market. So this is really what sets us apart. And we tend to enter the market with reentry solutions. And then users and customers see that actually we offer a suite that covers not only reentry, but the flight. And I think that's how we are going to stand apart.
Interesting. I think you briefly touch upon that part where I think the kind of collaborations you have, uh, but still from the capability enhancement perspective. So has Rike partnered with any space agencies, research institutions, or any other, even the companies or the organizations, to enhance its capabilities or the current existing capabilities that you're working on at the moment?
Mhm. Definitely. So for space agency, of course, the European Space Agency is not really a partnership, but for example, we are part of a aerothermodynamic workshop that allows us to benchmark our software solution. As we did mention previously, that market education is one of the biggest challenge, and validation is one of the primary point that we have to bring to our clients when we are bringing in a new solution in this market. So I would say this is one of our biggest can we call it a collaboration with the European Space Agency to benchmark our atmospheric reentry solution. And then we are also in touch with some other space agencies in Asia right now. As for research institution, we are partnering with EPFL in Switzerland. So Rike is an industrial partner for a PhD student who started in June, mainly working on atmospheric reentry predictions once again. And other companies to enhance their capabilities. Of course, there are a few companies like active debris removal companies or subsystem companies in the UK, in Germany, and we are also talking with a few software providers in Japan, for example. So these are a few existing partnerships that we have been working on since we started.
Interesting. And I would say, you have been working with several of these organizations and entities as well. So could you share some recent milestones or achievements that your company is particularly proud of?
Yes, so the most exciting definitely is to get pilot projects and bringing clients on board. That is one of, that brings traction, and that is the most exciting milestones that we have been achieving in Rike. And currently, I would say it's also the team expansion, which means it's a good sign. We have key milestones that we would like to achieve in our specific timeline. So we definitely need more hands on board. So
Yes,
having new team members in the team is definitely going to help us move forward faster and achieve our short-term goals, I would say. And
yes,
then technical wise, of course, I think our software is currently in version 3, working towards our 4th version. So that is also another achievement, I would say, technological wise.
that's great. Absolutely. And, I mean, just to kind of, take a little bit step back and think about the goals. So, what are your company's short-term and long-term goals for the future? Because I'm asking this question because, you have a very vast array of things to do. I mean, if you're in software, I mean, there are several things you can do on an innovative
Mhm.
scale to solve the issues. So, from that
Yes.
perspective, like, what are your short-term and long-term goals for the future?
So short-term goals definitely acing our current pilots and proof of concepts. So to do that, we want to build a strong team, help us develop and robustify our software solution, and to ensure successful pilots, successful proof of concepts, and have um, yeah, and that is our short-term goal. Long-term wise, we did do our introduction in the very beginning where we aim to bring automation to space operations. So this implies bringing AI on the edge solution on board spacecrafts, and there will be autonomous navigation for satellites, autonomous payload management, end-of-life management for satellites. So this is really the long-term goal that we are currently building using our existing software. And to achieve that, yes, definitely we need to go step by step, have a robust
Yeah,
software right now, and the long-term goal I think we are looking towards in the next 3 to 4 years.
yeah.
Mhm.
Absolutely. That's great to hear, actually. Yeah. I think the team expansion thing, as you mentioned, I think that's very crucial when having the brightest mind in the team makes a lot of difference, basically. And
Definitely.
yeah. And coming to the point where I think this is a very interesting question, because this question I get asked by several of the people in the industry and from outside of the industry as well whenever I speak about space debris management, that is the regulatory aspect. So, how does Rike navigate the regulatory landscape related to the space debris management? Because I believe, for XYZ country has a satellite and some third party countries removing it, I think there are some rules and regulations or the kind of, monitoring aspect that come into the play. So, from that perspective, do you see any kind of regulatory hurdles, or how do you see basically if there are any hurdles, and how do you see to navigate it in this domain?
I think the first part of this answer is that at the moment there are no laws, right? There are no laws that control space debris proliferation, space debris
Yeah.
management, or even space sustainability. So that's one thing. But what has been happening since maybe I will say 5 6 months, is different space agencies around the world are starting to establish strong recommendations and strong regulations, right? So it's the first step in the right direction, at least that's what we believe, in the right direction of establishing clear rules around this proliferation of debris.
Yeah.
So on our side, what we do is, well, we were from the start, from the very start of this ESA Zero Debris initiative, we were there in the workshops discussing with the other actors in Europe about the different aspects of the Zero Debris Charter that ESA put together. And this Zero Debris Charter is not a set of laws, right? Not yet, but it is the first step where we have a large dozen of items on this charter that really start to delineate how the end of life of spacecraft should be handled, and how the collision probability during the entire life of a spacecraft in orbit should be computed, and what is the maximum that we would allow, basically. So we have been
Interesting.
engaged with this initiative since the beginning. This charter is an ESA charter, but of course it is something that we wish to broadcast to everybody else in the world. Right? It's not because it was written by ESA that only European partners should follow it or read it or be part of it. So every time we have the occasion to do so, we mention that charter to our partners, to the people we talk to the other companies across the world. Right? Agnes mentioned she was in India. I was in Japan a while after that. So this is something that we really believe will be important in the coming years. And FAA has been doing the same kind of effort on their side, and FAA also started emitting fines for some non-compliant people. Sorry, non-compliant companies in space. So it's really moving. It's really moving, right? We are gaining momentum
Yes.
in and awareness in space sustainability. So this is the first thing. The second thing that we do is that we are not only discussing with ESA about this charter, but we're also trying to discuss with ESA about the compliance of our solution to the charter, and also to the rules that are around launching a new satellite in space. Right, there are a lot of rules, there are a lot of items and elements that you need to provide the launch office, the launch company when you want to launch something in space, and we are working towards making our solution compliant in the sense that it can be used sooner than later, hopefully, to actually put together these kind of files and these kind of bullet points for launch, right? So Recase software will be one of the softwares that people can use to validate their simulations and their mission design. And the last point, which I brushed a little bit with the ESA Zero Debris Charter, is really about quality advocacy. Well, I talked about this already. We mentioned these efforts that ESA is doing to all that we can, and we try to follow them, and we try to instigate the same kind of ideas and initiative in the heads of other partners. And we also keep on trying to build collaboration with different actors in the space industry, not only in Europe, everywhere internationally. Try to build collaborations to really build this network of people and companies and entities that have space sustainability in mind. Right? Even no matter what they're doing, no matter what aspect of the space industry they're tackling, we are trying to build this this network of like-minded people in the sense of space sustainability.
Interesting. Yeah, I think that's quite an extended perspective. I believe people will be getting quite a lot of answers out of this extended perspective. And taking a step ahead, I think from the regulatory aspect into the market demand, I would say. So, how do you access the uh, market demand for space debris solution? And from your perspective in general, from your experience in the industry from so many years, what trends are you observing in this domain?
Mm, so the market demand, there is definitely the growth in satellite launches. So the rapid increase in satellite launches, particularly from commercial entities deploying large constellation. So this has significantly heightened the demand for effective space debris solutions. With thousands of satellites expected to be launched in the coming years, there is a need for debris mitigation and space traffic management, where this issue is becoming more urgent. And then there is also industry and government initiatives. The government and space agencies worldwide are now prioritizing space sustainability, and this leads to implementation of stricter regulations, for example, and guidelines for debris mitigation. And as for trends, I think it's once again related. So the regulatory landscape is definitely evolving very fast with new policies and guidelines being introduced, the one like Thibaut mentioned of the Zero Debris Charter. And companies are increasingly investing in solutions that ensure compliance with these regulations. So this drives demands for, of course, innovative and effective debris management technologies. Another trend that I would say is also integration of AI and machine learning. So the integration of AI in space operations is becoming increasingly prevalent. So these technologies are being used to improve the accuracy of debris tracking, for example, and also to develop predictive models that can anticipate potential collisions and suggest avoidance maneuvers ahead of time. Yeah, these are the main trends that we observe and that we thought of when it comes to the space debris issue.
Interesting. Yeah, I think you mentioned AI quite a lot, I think, throughout the conversation. So I hope we are going to see quite a lot of evolution in terms of the way AI gets integrated into the space industry. I mean, we seriously haven't seen the full potential unlocked at the moment yet, the way I think we are seeing in the content writing, chat GPT and all. But yeah, I think in the future we might see, and I think your company might be one of the flag bearer, I would say, innovative companies to set that stage or set that mark. Basically, I hope so in the future. And finally, coming to, I think, the last part of our podcast actually. So finally, how do you envision the space industry evolving in the next decade, and what role do you see Recap playing in that future? As I mentioned, about the AI right now at the moment, so you can, mention in whichever way you feel your company might be playing a key role in the future in the space industry.
So this is a very, I think it's a very exciting perspective to look at. So the space industry, we can't really say right now what it is exactly going to be, but maybe there are a few things that we can guess are going to happen. The first thing, of course, that we want to emphasize, and hopefully it's not only wishful thinking, is that sustainability and space debris management is really going to become an integral part of space exploration, right? So Agnes mentioned it. We have an increasing number of satellites, increasing number of space missions. We are doing great things without orbital space. We are really providing and finding solutions for earthbound problems using satellites and using space technology, which is great. And what will happen in the coming years, it already started, is really sustainable practices are going to be enforced in the space technology of
Interesting.
the world in general. And this is not going to stop at those regulations and recommendations that the space agencies are putting together at the moment. Hopefully, it is going to go all the way to real international agreements and real set of rules, if not laws, to frame the use of our orbital space and to give a very strong frame to, okay, how do we do space missions? Basically, how do we do it, and how do we deal with
Yes.
the end of life of our spacecraft? I think this is one thing. The second thing, of course, that is even more exciting is space exploration itself, right? As we
Yes.
grow in maturity, with our orbital space missions, we will also grow in maturity in how can we send spacecraft further and further. And there are talks about lunar missions these days. There are talks about manned mission to Mars, of course, and this is really exciting. And I will not even try to say what year this is going to happen, but there is something in motion there that we hopefully will see in the next decade, right? But all
Interesting.
this will probably also benefit from progress in AI that has been done in the past 20, 30 years by mathematicians and by researchers here on the ground. Not only generative AI that everybody has heard about by now with the burst of ChatGPT in November 22, but it's all those AI technologies that are actually benefiting from the burst of Gen AI, because everybody now is really, I mean, there is a craze around AI, right? That really
Yes.
has become, and people are studying AI, people are working with AI, and people are realizing that this is a great tool, and we can basically do a lot of different things with AI that we couldn't really do, or we could do but less efficiently before. And the next step is, okay, what if we bring AI on board spacecraft, right? This is the goal of REK, really, to completely design an AI-based operating system for spacecraft. But there are many other things that you can do with AI as of today in your spacecraft. And I think these advances in automation and AI will really drive mission planning, will really drive space traffic management, and it will really drive space exploration. And just to finish, what is our role in all this, right? Well, our role in all this is to keep on supporting the growth of those sustainable practices, right? At the moment, we are already doing it with our platform, with our APIs. We are already supporting the growth of those practices by making tools available that companies, operators, satellite owners can use and leverage to really design their mission so that they are compliant with those regulations and
Yes.
recommendations, right? And what we want to take it to the next level of course, which is to bring everything in the spacecraft itself, that the spacecraft can do all these things autonomously, so that human operators can focus on what AI cannot do yet. So this is really, I think, this is the way we see ourselves right now, with the position of support to these sustainable practices at the moment, but growing into a provider of real AI and automated systems for spacecraft that will also include from scratch sustainable practices.
Interesting. Yeah, I think we have discussed quite a lot in detail, but I believe, definitely we can, if there are any questions, we can definitely organize another podcast as well. Because I believe this topic is, I mean, we can go on for hours and hours basically when it comes to space debris, when it comes to the technology, the kind of, utilities in terms of AI and everything that can be used basically. So, yeah,
Yeah.
zooming out from the actual topic that we were discussing, I believe every expert who comes on this podcast has something or the other to offer in terms of anecdotes to the current students, research scholars, experts, or the people from the outside of the space industry are trying to make a way into the space industry with their, innovative ideas or the kind of business models they have. So this last question is basically not related to our topic, but primarily to let people know what you as an expert think and might help or inspire the future generation to take a step into the space industry. So, what message would you like to give to the researchers, students, and experts working in the space industry or who are trying to make their way into the space industry? I mean, any of you can answer, or both of you can answer together as well. So, anything is fine.
Yeah. Well, for those engineers and technicians and researchers that are trying to make their way in the space industry, I'm just going to say, well, please come, because we do need brains, we do need hands in the space industry, right? We are at a point where we know how to do a couple of things quite well. We know how to launch rockets. We know how to put satellites in orbits. But there is so much more that we still need to learn. So everyone that is keen on trying, I would just welcome them to really try and enter the space industry at different levels, of course. But now for a more maybe a more global message, what we really have found out is that for this whole space sustainability issue, um, collaboration between the space actors, be it operators, be it agencies, be it OEMs or
Yes,
satellite owners, I believe, and I think Agnes is with me on this, I believe that collaboration is going to be also something that is going to unlock the next level of space exploration. Because at the moment, when we talk in conferences, when we talk in workshops, when we have chat with operators and other actors, there's always one thing that stands out, which is it's about the collision avoidance, for instance. The one thing that stands out is, okay, we pick up our phones and we call one another and we just decide on the spot who is going to move first. And this in 2024 is a little bit strange, right? We're not used to doing this. Everything is almost instantaneous nowadays. Aircraft, there is no picking up the phone, right? Aircraft do avoid each other in the sky. There is no issue with that. So it's an anecdote, but it's really a sign that collaboration, if we can figure it out the same way that we figured out international regulation for aircraft, I think it's really
yes,
going to unlock something else. Right? It's going to unlock the next level of space exploration, because in our own orbital Earth, everything will be running smoothly, so our efforts can be put on something else.
absolutely. Yeah, I really agree with your part about the collaboration. I think we are a very small industry as compared to, IT or electronics or any other industry. Space industry is a very small community. I mean, everyone
Yes.
knows each other, and I think collaboration is the key. Having partnership rather than looking at each other as competitors, we should always look at, how basically we can collaborate and innovate things and possibly grow together. Because, at the end of the day, the more we try to work together, the more innovative things definitely we can build. And I think as Walt Disney, or I think even the Steve Jobs used to say that, the most important thing to build something is the people. And I think the collaboration is something that brings the people together. So I believe, yeah, coming to the back to the point, I believe we had a really great conversation. So thank you very much, Agnes and Thibaut, for providing great insights on your company, the kind of work that you're doing, and I wish you very all the best to grow. And I hope to see more and more innovative services, solutions to coming out of your company in the future, because I believe this part of space debris and the space sustainability is something that we really need to tackle in the industry. Otherwise, the things for the humanities are going to be much more harder in terms of launching any kind of mission in the future in the low Earth orbit, especially. So yeah, thank you very much.
Thank you very much for giving us this opportunity. Okay.
Thanks,
Yes.
Omkar. It was great.